Hey everyone, on this lesson we are going to study the bubble sort algorithm for sorting elements in a sequence. Bubble sort is a simple sorting algorithm that repeatedly steps through the input list element by element, comparing the current element with the one after it, swapping their values if needed. The algorithm will finish when no changes occur in one of the steps. Let's see an example. We have this sequence. We start. We compare 6 and 5. 5 is less than 6, so we move 5 one position. Now we compare 6 and 3. We move 3 one position to the left since it is smaller. The same for 6 and 1. We compare 1 with 6, we move 1 position to the left. Now we go 6 and 8. 6 is less than 8, so we maintain the same. Now we go 8 and 7. 7 is smaller. We move 1 position to the left. And as we can see, at each pair of adjacent elements, we compare their values, right? We do it over and over. 4 is less than 8, so we move 1 position to the left, like so. We have completed this path. Now 8 is at its correct position. Now we compare 5 and 3 again. 3 is less than 5. Now we go 5 and 1. As we can see, 1 is less than 5, so 1 is going to be moved to the left, right? And we can do this over and over, over and over. Now, the next element that will be at its correct position is the element that is at the last but position. So basically, the element previous to 8, right? This penultimate element, which is 7, is going to be at its correct position. So we know for sure that now 7 is where it needs to be. And we will do this over and over, as we can see. All the elements in their correct position. So how is the implementation of this algorithm? Well, the idea is that given a vector of elements, if we want to sort these elements with bubble sort, we have initially a boolean that indicates if the sequence is sorted. Initially is going to be false. We get the last element. We can easily get it with the size of the vector -1. With this we get the index where the last element is. So while the sequence is not sorted, we define now the sorted to be true, and now we do here a loop. And if we encounter that one element on the left is greater than one element on the right, then we swap those and we also say that the sorted is false. Now, keep in mind that this for loop establishes and represents the path that we do. For instance, we do a path when we indicate the element at the last where its position is going to be at the right position. So here we are doing a path, right? So when is going to terminate this path? Well, the path is going to finish when now we establish 6 to be at its right position. 6 is now in its right position. We have finished a path. This means that we have finished this for loop. This for loop is nothing more than the path we do, okay, to establish the element at the right on its correct position. Again, we have done another path because 5 is in its correct position. So we keep doing paths and paths over and over until that sequence is sorted. If we find something that is wrong, we just say, okay, the sorted is false, and we are going to again go to this while loop and do another path, right? At the end, keep in mind that the greatest element is going to fall to the bottom. What does that mean? Well, initially, as we know, 8 is going to be the last, right? We are going to, okay, 8 is going to be the last position. But now, we know that 8 is already in its correct position. We don't need to swap 8. So now we decrease the value of last in 1 unit. So now the last is 4, right? The last element is 4 because we don't need to compare 8. 8 is already in its correct position, so 8, we just leave 8 there and we don't do anything with 8. So now that's why here we decrement the value for last. Now the last element is this one, okay, this element 4 here. And once we have that 7 is in its correct position, as we can see before 8, when we do this swap here, now 7 is in its correct position, we again decrease the value for last in 1 unit. So now here is last. We again do a last. So as we can see, we decrease the value for the last variable at each time that we finish a step, at each time that we finish a path. and this is obvious. At each time we finish a path, we know the element in its correct position, right, in the right, so we have to decrease the value for last. Again, we know the 6 is in its correct position, so now we only need to swap the elements here on the left. So we update the value for last and we decrease it in 1 unit. Very well. With this said, let's apply this algorithm with one example. Let's open our environment and let's apply the bubble sort. We are going to apply this in C++. You can generalize this algorithm in any imperative programming language. We're using Visual Studio. Again, you can use any IDE that you're familiar with. We are going to just, since in C++ we want to display the output, we are going to include the input and output stream. Since we want to use vector, we also need to include a vector library, and to avoid using std notation, we can just use a namespace for the std, right? So now let's define the main program. We need to apply this bubble sort. Let's consider that we have a vector of integers, okay, as we've done in the selection sort and also in the insertion sort examples. Let's define this vector to be v. It will consist of a vector of 5 elements, and let's now define this vector to be the vector 3, 2, 5, 1, 4. So we have this vector. We want to sort this vector, let's imagine now, in increasing order. So let's define now here the bubble sort procedure. So here we define bubble sort. Given a vector v of type integer in our case, we are going to pass this vector with reference. In C++, we always pass the vectors with reference for efficiency. And now keep in mind that the updated vector, that means the solution vector, the sorted vector, is going to be inside the same vector v. Okay. You could also program a function that returns the new vector, and you have the original one and you also have the new one. We are going to update this same vector, and we are going to now have the vector sorted in the same vector v, right? So let's start. Initially, we need to work with a Boolean variable that will determine if the sequence is already sorted or not. Initially, it's going to be false, right? Then we need to access the position where the last element is. So this position can be trivially computed as the size of the vector minus 1. With this, we get the last element index, right? And now here we basically do the while loop. So while the sequence is not sorted, we are going to set the sorted to be true, and then we are going to do a path. So here let's define the path to be from the initial element. We always start from the left until the last, and that's why we are going to decrement the last at the end, because at each path this last is decreased in 1 unit. And here, if we find that the element at position I is greater than the element at the next position, then we know that the sequence is not sorted. So first of all, we swap those two elements. We swap the element at position I with the element at position I plus 1. And then we also say, hey, we tell the algorithm that the sequence is not sorted. So sorted is false. Keep in mind that you need to also tell the algorithm that the sequence is not sorted, right? So we again do another path. Very well. Now the only thing remains to do here is once we have finished this path, once we have done this path, the only thing that we need to do is to decrement the value of last, right? This is basically the idea that we've explained before. If we already have that now 6 is in its correct position, now the last element is not 6 but 4, right? We need to update here the position index where the last element is. So we decrease it at each time that we do a path. Very well. So with this we have the bubble sort algorithm implemented. So let's apply this algorithm in this vector. So first of all, let's print the vector without sorting is, or let's just say without sorting, and an end of line. And here we just print all the elements in the vector. So we can easily do this with a for loop, and we print each element of the vector with a blank space. Okay, we separate the elements by blank so we can visualize them easily. Once we have print the elements without sorting, let's apply now the sorting algorithm, which is bubble sort. So here bubble sort to the vector v, And now we have the vector sorted. So now let's apply here vector after bubble sort. And we also print an end of line. And here we do the same thing. We print the elements, right? And now we should see the elements sorted. Also, let's add a line break here and also a line break here. Okay, merely for our presentation. So what we are doing, we are first printing the vector without sorting. So this here should print 3, 2, 5, 1, 4. And then we are going to sort the vector using the bubble sort algorithm, and we are going to print the elements, right? So let's run this. To run this in Visual Studio, you can just go to debug and start debugging to run the program. If you're using another IDE, then you just run your program as you normally do. So we press F5. And as we can see on the output, we have the vector without sorting. This is the original vector that we have. And then we have the vector after bubble sorting. As we can see, it has sorted in increasing order correctly. Now, what if instead of sorting this vector in increasing order, we want to sort it in decreasing order? Is this possible? Well, the answer is yes. If we have any sorting algorithm and we know how to sort the elements in increasing order, we also know how to sort it in decreasing order. So what do we need to change here? Well, the only thing that we need to change is this comparison. The idea is that if now we find an element smaller in the left, we need to say that the sorted is false. In this sense, we are going to put all the elements that are greater in the left and then the ones that are smaller on the right. So we will have the decreasing order. Again, we go to debug, start debugging, and as we can see now, we have the vector in decreased order, right? We have the original one, and then as we can see, the vector after bubble sort in decreasing order is this one. So as we can see, it is very simple. Let's just leave here the main increasing order notation. So if we find that this is greater than, we remind the student that you can download this code on the downloadable documents of this lesson. And remember that the bubble sort algorithm, like the insertion sort or the selection sort, is a quadratic sorting algorithm. That means that we have a time complexity of big O of n squared, where n is the number of elements, right? On the next lesson, we will see and study a new algorithm, which is the merge sort, which is a divide and conquer algorithm. And this merge sort technique is very efficient when sorting elements. And we're also going to see that its time complexity is no longer quadratic. The merge sort time complexity on the average case is n times the logarithmic of n. We will study this algorithm on the next lesson.